So here we're talking about the current in an electrical conductor varies inversely with the resistance of the conductor. They're actually telling us what variables to use. So they're saying I is going to equal the current. So I'm going to write that down here. I equals the current in an electrical conductor, and R is going to equal the resistance of the conductor. And the current is 1/3 amperes. So the current is measured in amps, and the resistance is 360 ohms. So whenever we're talking about ohms, we're talking about resistance. We need to find the current when the resistance is 15 ohms. So let's see how these things are varying. So the current varies inversely with the resistance. So I is the current. It varies inversely, so that's K over R, the resistance. Now it says the current is 1/3 amps, so current is I, and it says the resistance is 360 ohms. So those two go together. So we're going to put 1/3 in for I, and in place of R, we're going to put 360. And now I'm going to solve for K. And I'm going to solve for K by cross multiplying. 3K equals 360. Divide both sides by 3, and K equals 120. So our specific formula for this problem is I equals 120 over R. And now we can find the current when the resistance is 15 ohms. So the current is I, and we want to find that current when the resistance is 15 ohms. So 15 goes into 120. You could take out your calculators if you'd like. You could also do this off to the side by hand. 120 divided by 15 is equal to 8. And because this is a word problem, we need to label. So current is measured in amps. So 8 amps is going to be our answer. So when we have a resistance of 15 ohms, our current is 8 amps. Okay, the illuminance E of a light varies directly with the intensity. Intensity is I, measured in candela, of the light, and inversely with the square of the distance from the light. Wow, that sounds like a lot. It sounds like so much that I'm going to highlight. The illuminance varies directly with the intensity, that's measured in candela, and inversely with the square of the distance from the light. So that's a lot. So E is equal to illuminance, and illuminance, not sure what that's measured in yet, so I'm just going to keep that off to the side. I equals the intensity, but we know intensity is measured in candela. So I'm going to put that in parentheses so I don't forget that. And then inversely with the square of the distance, D. So capital D stands for the distance, and I don't yet know what that's measured in. The next sentence is going to tell me at a distance of 20 feet, so the distance is going to be measured in feet. A light meter reads 6 units. 6 units. So illuminance must be measured, right? The illuminance of a light meter reads 6 units for a 100 candela lamp. So 6 units. Units must be the illuminance. So let's go ahead and write down, before we figure out, we need to find eventually the illuminance reading of a 54 candela lamp at a distance of 18 feet. So before I do that, I got to go back to the first sentence and write down my general formula. Illuminance, which is E, varies Now directly and inversely, so I'm going to have a fraction. K is always in the numerator, varies directly with the intensity, I, and inversely with the square of the distance. So not the square root, but the square of the distance. Okay, so that's our first step. Second step is we need to plug in some numbers. At a distance of 20 feet, so I'm going to have 20 squared. A light meter reads 6 units. Ooh, 6 units was our illuminance. For a 100 candela lamp, so I've got K times candela is our intensity, so 100 is going to go in to the numerator, right, with K. Now I need to solve for K. So I'm going to cross multiply 6 times 400 equals K times 100. I'm going to need a little bit more room here. 2400 equals 100K. I'm going to divide both sides by 100, and K equals 24. So our specific formula for this problem is E equals 24 times I over D squared. Now it says find the illuminance. Illuminance is going to be E, so we're going to find the illuminance reading of a 54 candela lamp at a distance of 18 feet. So E is equal to 24 times 54 divided by 18 squared. Now I'm doing this on purpose because I want to show you, you can use your calculator, 24 times 54 divided by 18 squared. But I'm going to show you something when you don't have a calculator. This is some really good arithmetic here. 54 divided by 18 happens to be 3. So I'm going to cancel that out. And then 3 goes into itself once, and it goes into 18 6 times. So without picking up a calculator, I've got 24 divided by 6, which is just 4. And the illuminance reading is measured in units, so I get 4 units. And I didn't need to pick up a calculator, which is a pretty cool thing. So just wanted to show you that arithmetic. Whenever I get the chance to do that, I love to take those opportunities and use them. So those are some pretty good examples of variation. I've got 2 more problems that are definite tries. 2 more problems that are definite tries that we're going to do in the next video. So these 2 problems right here are going to come up in the next video. I'm going to provide the answers and the work. So you can take a look at these, press pause, write them down, try and work them out. And when you come back in the next video, you're going to get the answers.